There's several types of cryptography techniques, from the simplest techniques to the more complicated ones that protect our data and credit card information when we go online. But I just want to show you, before I get into this, a real simple way to encrypt a message. Let's say you wanted to write my name in a secret code. Well, one way to do that is just to move the letters of each letter of my name one space to the right. So the K would become L, the E would become F, the V would become W, the I would become J, and the N would become O. Now, you don't have to move it one space. You could actually say, I'm going to move it 3 spaces or 5 spaces. For example, if you moved it 3 spaces, the K would become LMN, the E would become FGH, the V would become WXY, the I would become JKL, and the N would become OPQ. Now you could easily, so if we were working together, all you'd have to do is know that I shifted the letters 3 spaces, and then you could just shift these letters back 3 spaces to decode the message. Now, obviously that's not a very secure message, because it would be very easy for someone to eventually figure it out. So when you're encrypting and giving secret messages, you want to try to come up with some method that actually makes it more difficult for the message to be broken, make it as difficult as you can. But what you want to do is you want to have it to where it's not worth someone's time to go to all the trouble or the money that it would cost to decode the message. So anyway, there's books on cryptography that you can read if you would like to. What I'm going to do here is I'm going to show you how to encode and decode messages using matrices. So let's assume that A, the first letter of the alphabet, A, just represents the number 1, and B is represented by the number 2, C is represented by the number 3, and so on. And let's suppose if we wanted to use blank spaces, we'll just use 0 for a blank space. You could actually use any number that's not 1 through 26, but we'll use 0. So let's say I wanted to encode the message secret code. Well, if you go back and look at your alphabet, and I'll let you do that, you'll see that S is the 19th letter, E is the 5th letter, C is the 3rd letter, R is the 18th letter, E is the 5th letter, T is the 20th letter, and for the space we'll put a 0. C is the 3rd letter, O is the 15th letter, D is the 4th letter, and E is the 5th letter. Now, we're going to get a matrix out of this. And so we need to be careful in how we put this into a matrix, because I'm going to go ahead and give you the encoding matrix first. So if you'll notice here, I'm going to use this matrix to encode my message. Now, what's important about this matrix is that this matrix is a 2 by 2 matrix. And so I'm actually going to take that matrix and I'm going to multiply it by my message matrix. But remember, in order for us to multiply 2 matrices together, the second matrix, the number of rows in the second matrix must equal the number of columns in the first matrix. So I've got to make sure that my matrix that I'm going to put the message in is a 2 by. Now I don't know how many columns I'm going to need, but I do know it's got to be 2 rows. So therefore, when I put my message numbers here in a matrix, I need to put it in some sort of 2 by matrix. So here's the way to do that. This is the way you can do it to make sure it's in a matrix with 2 rows. Just take the first 2 numbers and make them be the first column. So the 19 and 5 would be the first column. Then take the next 2 numbers, the 3 and the 18, and make them the next column. Then make the next 2 numbers, 5 and 20, the next column. Then 0, 3, the next column. Then 15, 4 be the next column. And the 5 is going to be in the last column, And since I have an odd number of values here, I can't leave this empty. So I'm just going to put a 0 in here. That just pretends like I have a space beside the E here. So we got to put something in there. So we're just going to put a 0 in there for a space. Okay, so there is my message matrix. Now again, if you want to read this, you can see this is SECRET space CODE space. Okay, now this, since I'm going to use this as my encoding matrix, what I'm going to do is I'm going to actually multiply this matrix here times this matrix, this message matrix. And since you've already been taught how to multiply, I won't spend a lot of time on this, but if you multiply this row with this column, you'll get 4 times 19 is 76, plus 3 times 5 is 15. 76 plus 15 is 91. If you multiply this row with this column, you'll get 4 times 3 is 12, and 3 times 18 is 54. 12 plus 54 is 66, and so on. And then, of course, you also have to multiply this row by each column to get the bottom row. Okay, so this would be the resulting matrix. So now I would take this out in reverse fashion of the way I put it in. So since I put it in column by column, I'm going to take it out column by column. So take these numbers out, and I get 91, 24. So I get 91, 24. And then the next column, 66, 21. And the next column, 80, 25. The next column is 9, 3. Then 72, 19, and then 25. And so that is the encoded message. Now, if I send this message to my counterpart, then, or my partner, then that person could actually take this message and put it back in this form right here. They could take it and put it back in this form right here. And then all they have to do to decode the message is multiply this matrix by the inverse of the matrix I used for encoding. All right, so let me show you. So the inverse of this matrix can be shown to be this matrix, 1, -3, -1, 4. So now let's say I send this message to my partner, this encoded message to my partner. My partner now needs to decode the message, so they put this message back into matrix form. So here it is, right here, in matrix form. So they put it back in matrix form, and then they get the inverse of this matrix, and they simply multiply this matrix by the encoded matrix. Now, notice here, if I multiply, you can check this. I'll just check it for a couple of them. If I take this row with this column, I'll get 91 minus 72, which is 19. If I take the second row times this column, I'll get minus 91 plus 96. That'll give me 5. If I take the first row with the second column, I'll get 66 minus 63, which is 3. And if I take the second row with the second column, I'll get minus 66 plus 84, which is 18, and so forth. Now you can see what's developing here. We're getting the 19, the 5, the 3, the 18, the 5, the 20, the 0, the 3, the 5, the 15, the 15, the 4, the 5, the 0. We're getting that back. So now once they've multiplied by the inverse, it gives them back the original message matrix, and then the person on the other end would simply have to take that out, take those numbers out, and then look at their alphabet key, and they could tell that this message actually says secret code. Pretty cool, huh? Now, to give this a more practical sense, think of this, instead of it being the word secret code, what if this was your credit card number? Well, then you could put your credit card number in a matrix, and then you could use some 2x2 matrix to encode it, and it would basically, when you multiply that 2x2 matrix by your credit card number, it would basically jumble up the numbers. And then the person on the other end, obviously somebody that we want to be able to read, like Amazon.com or some store that you buy something from, they can then use their matrix, which would be the inverse of that, to decode the matrix, and then they would have your credit card number. Now, of course, the trick is you don't want anybody intercepting that message along the way and being able to decode it. But trust me, there's actually a lot more advanced cryptography methods being used to encode our credit card numbers and things like that. Okay, let me just show you one more example here. Let's suppose that I was afraid that using a 2x2 encoding matrix was going to be too simple for someone to decode. So let's say I wanted to put my message secret code in a 3x3 format. Okay, well, it's still the same message and the same numbers, but if I'm going to use a 3x3 matrix to encode it, then this needs to be in a some sort of 3x matrix. So in that case, I would have to take out 3 at a time. So I would take out 19, 5, and 3, and that would be my first column. And then 18, 5, and 20 would be my second column. Then 0, 3, and 15 would be my next column. And then my last column would have 4 and 5 in it, but since I can't leave that empty, I'd put a 0 there. Now, I can use this matrix here to encode the message. So I can take this matrix A and I can multiply that matrix times the encoded message matrix, the message matrix that I have up here. And when I multiply these together, you can check my arithmetic here, but I actually got this for the message. So now the encoded message, if I take it out in reverse of the way I put it in, I'd have 17, 7, 53, 33, negative 10, 51, 12, negative 9, 9, negative 1, 10, 23. And that would be the message that I would send to my partner. Now, what my partner would have to do is my partner would have to find the inverse to this matrix, and then my partner would have to multiply this message matrix here by the inverse. And if my partner did that correctly, then the partner should end up with the original message in the matrix, and he can read off the original message from the message matrix. All right, here's a practice problem that I got out of a book, and you can probably tell from the answer it actually came from some nerdy math person who decided it would be cool to put in who is Carl Gauss. But anyway, the encoded message here, so this is the encoded message. So this is after the message has been encoded. So what you would have to do, since I told you it was encoded with this matrix, then you're going to have to find the inverse of this matrix. And I gave you a little hint down here. Here's the inverse of this matrix. So what you would have to do, since we're using a 3x3, you'd have to put this in a 3x3 matrix like I did up here. So you have to put it in a not a 3x3, but a 3x matrix. Put it in here. So put that in a 3x matrix and then multiply it by this inverse. And it should give you the message, and then you'll be able to read off from that message when you get your alphabet key and look up where each letter is. You should be able to find out that the message says who is Carl Gauss. Now down here is just a note about encryption, and I'll just leave this for you, and you can read this on your own. I find encryption a very interesting topic, and it's especially important today with all of the online activities that we have. But I've got only one more topic that I'm going to talk about in this module, and that topic is actually on matrix properties, like the operational properties of matrices that you can do. So I'll wrap that up in the next video.